Hello, Namaste. This is Rohini Mirgu from Walchand Institute of Technology, Solapur. The topic is data conversion to the scale type. In the part 1, I have explained some conversions, and this is the remaining conversions I am explaining in this part 2. Learning outcomes. At the end of the video, you will be able to select the appropriate data conversion technique based on the characteristics of data set. You can apply various data conversion techniques. You can explain the significance of normalization and can apply the normalization to the given data set by using different techniques. This part we have already talked in part 1 also. This is the part of a data pre-processing wherein we need to convert the one scale type to other or the same scale type to same scale type, which is normalization. And in pre-processing there is one more part, dimensionality reduction and data transformation. Converting to different scale type, we have talked in part 1 about nominal to ordinal, relative, ordinal to relative, and then ordinal to relative and ordinal to absolute also we have done, and this part absolute relative to nominal ordinal will do, as well as normalization part will do in this video. So this video is basically focused on these two bits. So converting to different scale type, absolute or relative scale to nominal to an ordinal scale. Quantitative values can be converted to nominal or ordinal values. This process is called as discretization. And depending on whether we want to keep the order, the data converted can be nominal or ordinal. If we want the order, then the data can be ordinal. If you don't want the order, then the data is nominal. Discretization is necessary when the learning algorithm deals with only quantitative values or when we want to reduce the number of quantitative values. So in such cases, discretization is required. So when we are converting the scale type, let us revise or let us recall. Let us recall what are the different scale types in data science. So different scale types in data science are nominal, ordinal, relative, which is also called as an interval scale, absolute, which is also called as a ratio scale. Nominal scale is a categorical measurement scale where data is labeled without any inherent order. So there is no ordering in nominal. So example are the colors, orange, red and black. Ordinal scale, it is again a categorical data, but there is ordering or a ranking. So example is educational level and customer satisfaction. Next comes is a relative or interval scale, wherein the measurement of values is compared relative to each other rather than having the absolute reference. Example is temperature in degrees Celsius or Fahrenheit or IQ score. Absolute or ratio scale is the measurement scale which represent the real quantities with and it has a true zero. For example, height in temperature in centimeter, weight in kg, age in years. So this discretization, when we talk about relative or absolute to ordinal or nominal conversion, that is quantitative to qualitative conversion. So in such case, we have to go for discretization, and that discretization has two steps. First step is define the number of quantitative values that you want to in the output. So this number of quantitative values that we want are called as a bins. And each bin can be associated with an interval of quantitative values. That is the first method. Second is define the interval of values to be associated with each bin, and the association is done by an algorithm. This is the second step in this. And when we are doing this interval of values to be assigned to one bin, there are two alternative methods for it. One is conversion by width. There is the interval has the same range and the same difference between the largest and smallest values. So we look for largest and smallest values and we'll try to keep the same difference. Wherein conversion by frequency, the interval will have the same number of values. The number of values, that is frequency, will be same for each interval. So let us see this converting from a relative absolute, that is quantitative, to ordinal or nominal, that is qualitative. So here again this table is taken from João Moreira textbook. So the PPTs are focused on this textbook only, and the textbook is mentioned in the references. Here first we'll look for conversion by width. what is meant by conversion by width? The same difference between the largest and smallest values. Here we assume we want to form the 3 bins. So here my target is converted to quantitative wherein I want 3 bins. So I assume that there should be 3 bins like A, B and C. So this is my quantitative value which I want to convert to qualitative. So in qualitative I want 3 bins. So here when I want to convert into A, B, C, I have considered 2 to 7 as in A. Why? Because the smallest value if I consider here, it is 2, largest value is 7, so that if I see the difference, A is 7 minus 2 which is 5 which is assigned to bin A. Similarly, I can go for B where B is smallest value is 10, largest value 15. If I take the difference of B, that is 15 minus 10 which is 5 which can be assigned to bin C, bin B. And if I see for C, the C is 20 minus 16, that is 16 is the lowest value, 20 is the highest value. The difference comes out to be actually 4, but 3 equal bins are not possible, it is much closer to 5, so it can be assigned to bin C. So 3 bins formed which are by width. Let us look at the second method, that is conversion by frequency. So each interval have the same number of values. The total instances here are 9 and divide equal number of bins, that is 3 bins, that is 3 instances in one bin or one group. So let us consider total here as instances are 9. You can count. These are 3 plus 3 and plus 3, 6. So 3 should be considered in one bin. So this 3 goes to bin A, next 3 goes to bin B and next 3 goes to bin C. So this way we can convert quantitative to qualitative. Converting to different scale type, in this I can consider one method as normalization, where we are not converting quantitative to qualitative or any other, but rather in some cases we want the same scale to be converted. Like it transform the values of data set into some common scale. Why it is important? Because machine learning algorithms are sensitive to the scale of the input features and can produce different results when the data is normalized. So normalization to scale the data of an attribute so that it falls in the range between -1 to +1 or from 0 to 1. It is generally useful for classification algorithm, and normalization is the technique which is used in data mining. So here one example is given. Imagine the data set given to you which contains the house prices and number of rooms. So if you check house prices in dollars is very high value, and number of rooms, of course it can go to 3, 4, 5. So at the max it's 5 here. So these values are very much less compared to the values which are mentioned for house prices. So when we give this data to the ML algorithm will give high weightage to these values and lower weightage to these values, which is not expected actually. So in such case we can normalize that data. So we can normalize the data between into the values which is between 0 to 1 or -1 to 1 +1, but here they have normalized to 0 to 1. So this example, which is again taken from João Moreira textbook, so wherein he has given the example of 3 friends which have 3 friends names mentioned here with the age and education in years. The age is mentioned in years, education PhD, 4 is for PG, maybe 2 is for schooling part. So likewise the different education levels are mentioned, and the friends, again the same friends, Bernhard, Ganit and James, same education level is there of course, but the ages, instead of mentioning in years, here the ages are mentioned in decades. Decades means 43 divided by 10, so it's 4.3 in 3.8 and so on. So here we want to find the similar friends based on the factors such as age and education. So age in years when we take, so these friends ages in years when we consider, so we want to prepare the table of Euclidean distance between the friends and ages. So Euclidean distance between Bernhard and Ganit. So this is Bernhard mentioned by B and Ganit by G. So the distance between Bernhard and Ganit is, if I take the age is 43 and 38, so 43 minus 38 square, plus if I check the education level, it is 2 minus 4.2 square. So the value goes to be 5.46. Similarly, we can find the distance between Bernhard and James, B and J, and Ganit and James, that is G and J. So we'll get these Euclidean distances which can be put in this table. Here I have highlighted this value Bg, which is 2.33, because this 2.33 is the minimum Euclidean distance which is between Bernard and James, which indicates that Bernard and James are most similar friends as per when I consider the age in years. Let us see when I express the age in decades whether I get the same results. So age is expressed in decades, which is 4.3, 3.8, 4.2, and here again I'll try to find out the Euclidean distance between Bernard and Gannet, so which is 4.3 minus 3.8 square plus 2 minus 4.2 square. So the value goes to be 2.26. So similarly, I can find from Bernard and James, Gannet and James, and I can prepare the table, I can put it in the table. When I put it in the table, surprisingly, I find that the minimum distance is between Gannet and James, which indicates here the Gannet and James are the most similar friends. Whereas the result in the previous case is Bernard and James are most similar friends. So results are conflicting. So there is a need of normalization. So if we use years instead of decades, the measure of ages, we obtain larger numbers, much larger than the ones which measure the education level. So as a consequence, the values of the ages will be much more influential than that of education level in the calculation of Euclidean distance. So practical approach to avoid the problem is data normalization. So the typical pre-processing task should be done during this execution of data pre-processing phase, which is normalization, can be done by two methods, min-max scaling as well as standardization. So min-max scaling is the simplest alternative, converts the set of values in the interval between 0 to 1. If we want the values to be in the interval between -1 to 1, we can multiply this by the value 2 and the values which are obtained from 0 to 1 by 2 and subtract 1 from each of them. Then we get between -1 to +1. So first method which we are looking for, min-max scaling, why the name is like that? Because the rescaled value can be calculated as a particular value minus minimum of all that, minimum of the value of that attribute divided by maximum value of that attribute minus minimum value of that attribute. So we have normalized divided by max minus min. So the name is min-max scaling. So if we take the same formula is considered here, and this table is taken from the textbook Jao Mororia, which is used as a reference for these PPTs. So here we again mention this ages in years, and we find the rescaled age. In this rescaled age, if we check, the max is 43, min is 38. So 43 and 38 mentioned here, and rescaled age 43 can be calculated by using this formula, which is equal to xi stands for 43 minus min of age, which is 38, divided by max minus min, which is 33 minus 38, the value comes to be 1. Similarly, we can find out for 38, which is 38 minus all other values will remain same, which is 0. For 42, again only this first value, that is xi, is going to change. So 42 minus 38 divided by the same, so it is 0.8. So the values have been mentioned in this rescaled age. Okay, so the values have been brought between 0 to 1. Rescaled education also calculated by the same method, like education 2.0 can be calculated as xi is 2 minus minimum of these is 2 divided by maximum of these is 4.2 and minimum is 2, so 4.2 minus 2. So I'll get the value 0. Similarly, others have been calculated and have been put in this table. Again, the values I got between 0 to 1. Normalization by standardization is another method where we first subtract the average of the attribute values and then divide the result by the standard deviation of these values. As a result of the values we'll obtain are between 0 to 1. So standardization formula is rescaled x is equal to xi minus average of x divided by s, where s is the standard deviation. So this formula we are going to use for standardization. So first of all, for this we need average as well as standard deviation. So average age is calculated for these friends when ages are expressed in years is 43 plus 38 plus 42 divided by 3. So average we get 41. For standard deviation, the formula is under root of xi minus xi bar square divided by n minus 1. I need to sum up all those. So xi first is 43 minus x bar means mean, which is 41 bracket square, plus xi again is 38. I can take 38 here, minus mean x bar, which is 41 square, plus 42 minus 41 square divided by n minus 1. Total number of values 1, 2, 3. So 3 minus 1. So I get the value 2.65. Similarly, I can find out the average age for when the age is expressed in decades, which is 4.3, 3.8, 4.2, and so on. So we get this average is 3. For education, sorry, it's 2, 4.2, 4.1, it goes to be 3.4, and standard deviation calculated by the same method by using this formula. So we get it is 1.22. So when I use standardization, I get the table values like this. How? Because rescaled age, average age is 41, standard value is 2.68. So rescaled age 43. 43 means xi is 43 minus the formula is minus average of x. So average of x is 41 divided by standard deviation. So standard deviation is 2.67. So it is 2.65. I think here I made wrong. So it's 2.65. So the value goes to be 0.76. Likewise, I can calculate all other values. I can put it in the table. So here you can see the values obtained between minus 1 to plus 1. Again here, if I calculate the rescaled education, I get the values between minus 1 to plus 1. Now, the normalization using min-max scaling has given the age this, rescaled education this, and now I try to find the Euclidean distance 1 and 0.8. If I take, so initially between Bernhard and Ganit, I calculate the Euclidean distance. If I want to find between Bernhard and James, it is going to be 1 minus 0.8 square plus the another attribute I should consider, which is education, which is 0 minus 0.9 square, which is 1.03. Similarly, I can calculate Euclidean distance for all the attributes, for all the friends. So I get these values. So here minimum value is between Ganit and James. I calculate the same by using standardization technique. In the standardization technique, the rescaled ages between Bernhard and James, if I take, so it is 0.76 minus 0.38 square. Plus now I take rescaled education, which is minus 1.15 minus 0.49 square, and the value is 1.68. So likewise I calculate for each friend with respect to others, and I get these values. I can put it in the table, and I can see that the minimum value is 1.52. So in both the cases, I am getting the minimum value between Ganit and James. Now I can see that the most similar friends, of course, are Ganit and James and not Bernhard and James. And the most dissimilar friends are Bernhard and Ganit. So this is what is the conclusion, which is really very correct when we normalize the data. So this is the minimum value. So these are the references used for preparing this video. Thank you.